Welcome back. Today we're working in Module 13 or Chapter 13, where we're now going to look at incident preparation and investigation. So the cat is out of the bag, so to speak. We need to figure out what happened. We're preparing for that incident response. So, by the end of this module, you should be able to explain how to prepare for a cyber incident. Describe how to achieve resilience through redundancy. Describe how to conduct an analysis of an incident. Remember, this is now after the fact. So, in any business, the goal of the business is to keep operating. So this first term, business continuity, is the ability of an organization to maintain its operations and services in the face of disruptive event or disaster. Say like if the power goes out, or if there's a fire in a building or something, some other disaster. So business continuity has in its back pocket business continuity planning. And that's the process of an organization undertakes in advance to determine a plan of action in the event of a disaster. So you're going to have a meeting and plan and write out a series of steps that you would take. The outcome of this planning is a business continuity plan, or BCP. A strategic document that provides alternative modes of operation for business activities, and you should have several contingencies in there. Maybe you can't get the power back on. Do you have a backup generator? Things like that. Do you have an alternate site? We'll talk about those things. So a BCP, business continuity plan, should include the following elements: high availability, scalability, diversity, and on-premise and cloud. So the term continuity of operation planning, it's a federal initiative that is intended to encourage organizations to address how critical operations will continue under a broad range of negative circumstances. A business impact analysis identifies business processes and functions and then quantifies them, and the impact a loss of these functions may have on a business operation. What will happen if this happens or that happens? How big of a loss or downtime will we have with that? Your business impact analysis is designed to identify those processes that are critically important to an enterprise. It will then help to determine the mission essential function, the activity that serves as a core purpose of the enterprise. Another goal of the BIA is to identify the single point of failure of a system. The single point of failure is that one point where if it goes down, it's going to totally impact the organization. Okay. A subset of the BCP is called disaster recovery plan. Yeah, you've fallen down, you've hurt your knee. How are you going to get back up? The disaster recovery plan is a written document that details the process of restoring the IT resources following an event that causes significant disruption in service. One topic of a DRP is the sequence in restoring the system. That's the restoration order. Turn this on, turn that on, bring this online, do this. The factors that affect the restoration order include dependencies, the importance of processes, and alternative business practices. So steps to take in preparation for an incident: you create the incident plan, perform the testing exercises, study the attack frameworks. So your incident response plan is a set of written instructions for reacting to an information security incident and should contain the following: definitions, incident response teams, who, and reporting requirements. So remember now, in this chapter, we're not programming, we're not doing anything different or special about this, but we're going to be figuring out what to do. So it's important to test an incident response plan by conducting simulated testing exercises to make necessary adjustments. An information security framework is a series of documented processes used to define policies and procedures for implementation and management of security controls in an enterprise environment. So the frameworks can then be studied on how attacks occur, called exploitation or frameworks. So here's an example of a MITRE, ATT, and ACK framework. It starts from the left-hand side and expands to the right. You have your initial access, execution, persistence, privilege escalation, and so forth. Here's a diamond model of intrusion analysis. Okay, so you have your adversary at the top, you have your capabilities on the left, infrastructure on the right, and victims at the bottom. Because you want to be able to quickly assess what you have, what you need, and things like that. So let's check our knowledge activity number 1 here. Which of the following is not an element that should be part of a business continuity plan, or BCP? High availability, simplicity, diversity, or scalability. You remember we talked about this, and it's important because we need to make the right choice here. Because right now our system is down. We need to be able to figure out how to, how we're going to use business continuity plan to get ourselves back up and running. Those are high availability, simplicity, diversity, or scalability. Well, remember, not an element of that should be part of a BCP is your simplicity. Because you don't need your plan to be simple, but it needs to be effective. The business continuity plan, which is a strategic document that provides alternative modes of operation for business activities that, if interrupted, would result in a significant loss to the enterprise. Creating a BCP involves identifying exposure to threats, creating preventive and recovery procedures, and then testing them to determine if they are sufficient. By its very nature, a BCP does not stress simplicity. That's important. It's not necessarily simple, but it has to be effective. Okay, here's another one. Resilience through redundancy. Why is that important? Well, capacity planning is the process of forecasting the need for future resources. It involves calculating the following: future human resources, people capacity planning, predicting the number of devices needed, technology capacity planning, the size of the network, infrastructure capacity planning. So everywhere there you can see the capacity planning. It's whether it's people, technology, or infrastructure. Using multiple different devices to host or serve an application or service is known as platform diversity. Equipment redundancy can provide resilience in the case of a cyber attack. So if one server goes down, I can turn right around and plug in another server or turn it on, or if it's already on, just make it go online. So resilience through redundancy can also aid in incident preparation. It usually involves duplicated servers, drives, networks, power, sites, clouds, and data. We'll talk about more about this. So let's talk about servers. There is a need to be high availability in servers so that they are always accessible. It's not something, give me a few minutes, we'll bring it online. We need it now. One approach is to design the network infrastructure so that multiple servers are incorporated into the network but appear to users as a single resource. This concept is called clustering, or combining 2 or more devices to appear as a single unit. A server cluster is a combination of two or more servers that are interconnected to appear as one. When you do a Google search, you're actually accessing, I think, 20 or more servers to give you those results in 0.03 seconds. One does the ones that are numeric, the one that are country related, one that are people related, one that deal with numbers, one that deal with pictures, one that deal with other data. So each of them's broken down, and then they come back with the results, and that's what formulates the results that you get back. So here's an example of a server cluster. So you have the three clients, you have your public cluster connection, you have server 1 on the left, server 2 on the right. They have a shared disk. So the clients just see that as one server, but there's actually two servers here. So there are two types of server clusters. One's called an asymmetric server cluster. It's a standby server that exists only to take over for another server in the event of its failure. So it's on standby. In a symmetric server cluster, every server in the cluster performs useful work. If one server fails, the remaining servers continue to perform their normal work as well as that of the failed server. Virtualization has impacted the number of server clusters that are needed now for server redundancy. Let's talk about hard disk drives, or different drives. You have the hard disk drives, or HDDs. They're spinning platters, actuator arms with read-write heads, and motors to store and retrieve data. I don't know if you've ever seen the inside of a hard drive. They're like little discs. They're probably about 3 or 4 inches wide, and they're just like a little coffee cup or coffee tray, and they're spinning very, very fast, 5,900 RPM or 7,200 RPM depending on the model. Then you have solid state drives. They store data on chips instead of magnetic platters. They're more resilient to failure and more reliable than hard disk drives. They're not moving. They don't spin, so they don't have that necessarily risk of moving failure. Some organizations maintain a stockpile of hard disk drives as spare parts to replace failures in case the solid state drive goes down. So there's a term here called the mean time between failures. It refers to the average amount of time until a component fails. It cannot be repaired or must be replaced. Kind of like the changing of a flat tire. So how long are you going to drive before that tire goes flat? Or how long are you going to drive before you have to fill up the gas tank? Okay, that's probably not a good example, but the average amount of time until a component fails cannot be repaired or must be replaced. So in that case, if we want to have, since we're putting more and more data on our computers, there's a new term called a redundant array of independent drives, called a RAID. It uses multiple hard drives for increased reliability and performance. It can be implemented either through software or hardware. Software-based RAID is implemented at the OS level. Hardware-based RAID requires specialized hardware controllers, and there's several RAID configurations called levels. The necessary levels can combine either RAID levels 0 or 10 rather, is a combination of RAID level 0 and level 1. So here's an example where you have a RAID controller and you have disk 1, disk 2, disk 3, disk 4. This is a RAID level 0 technology is based on what's called striping. So the data is spread across these 4 drives, A, B, C, D, E, F, G, H, I, J, K, L, M, N, O, and etc. RAID level 1 uses disk mirroring. So those 4 drives are down to 2. You have 2 functioning drives. The other 2 are just a mirror of whatever that is. So disk 2 is a mirror of disk 1. Disk 4 is a mirror of disk 3. RAID level 5 distributes parity of data across all devices. So you can see here, you have your A, B, C, D, and E drives, and you have the parity across all of them. Okay, so on our hard drives, if you put them out on the server, you have what's called a storage area network. It's a dedicated network storage facility that provides access to data storage over high-speed networks. For instance, you might see what's called a network attached server, or another computer that has a server or a drive attached to it that's just serving the needs of the network. Okay. They consolidate different storage facilities that appear to serve as a single pool of locally attached devices. Okay. Multipath is a technique for creating more than one physical path between the devices and an SAN, your storage area network. If one path is interrupted, multipath would redirect the broken connection to another path. So in networks, a redundant network waits in the background during normal operations and uses a replication scheme to keep its copy of the live network information current. A redundant network ensures that network services are always accessible. Switches and routers can have a primary active port as well as a standby failover network port for physical redundancy. Load balancers can provide a degree of network redundancy by blocking traffic to servers that are not functioning. I remember before I mentioned like Yahoo, every 15 minutes through load balancing, it switches traffic to a different group of servers. So with all of this computer equipment, and it needs power, we have to make sure we protect the power. So an uninterruptible power supply, otherwise known as a UPS, is a device that maintains power to equipment in the case of an interruption to the primary electrical power source. With an offline UPS, if the power is interrupted, the UPS quickly begins supplying power to the equipment. When power is restored, the UPS switches back to the standby mode, like a train track. You ever see a train track switch from track A to track B? That's an offline UPS. An online UPS is always running off its battery while the main power runs the battery charger. So that means the hardware is always running off of a battery. And all it is if the power goes out, that's just interrupting the battery charger. It can clean the electrical power before reaching the server. With an offline UPS, there's a millisecond delay as it switches over. So these, you want to put a star by this one. This is important as far as your sites and redundancy. A hot site is generally run by a commercial disaster recovery service that allows a business to continue computer and network operations to maintain business continuity. A cold site, and by the way, that hot site is ready to run with very little startup if it's not up and running already. A cold site provides office space, but the consumer must still provide and install all the equipment needed to continue operations. So it's like going in and then you have to set up all the equipment and configure it all to make it run. So there's going to be some downtime with that. A warm site still has the equipment installed but does not have active internet or telecommunications facilities and does not have the current backups of data. So you can see you have a hot site, you have a warm site, and a cold site. Okay. Now, Let's talk about clouds. The following are two considerations for cloud resilience. The location of the data stored in the cloud, maybe spread the cloud computing across multiple cloud providers, multi-cloud systems. An advantage of multi-cloud is the organization is able to tolerate a critical issue that could occur with a single cloud provider. So that means if, say, one goes down, we can switch over to, provider B or C. So the resilience of the data is achieved by copying the data. So two calculations are used regarding when the data copy should be performed. There's what's called a recovery point objective and a recovery time objectives. The recovery point objective is the maximum length of time that an organization can tolerate between copies. A recovery time objective is the length of time it will take to recover the data that has been copied. So a backup is a single scheduled event where data is copied and then stored so that it can be used in the event of a disaster. Copies can be stored off-site or on-site or off-site. There are two techniques for data replication. A snapshot takes a picture of the state of the data repeatedly so that the data can be restored from a specific point in time, or journaling, which makes a copy of the data whenever there's a change to the data that occurs. So snapshot or journaling. Like some companies will do like a full backup and they do like a daily backup. That would be more like a snapshot. Okay, here's our knowledge check activity. So Chaya is helping an intern understand RAID. Which of the following is not something that Chaya will say about RAID? And I don't want to say anything because I would give it away. Which of the following is not something that Chaya would say about RAID? Okay, so it's going to be C. It's designed primarily to back up data. Although all levels of RAID except level 0 can offer protection from a single drive failure, RAID is not intended to replace data backups, but rather to provide an immediate live copy of data in the event of a drive failure. So, designing primarily to back up data is not something that Chaya would say about RAID. Okay. So we need to figure out what happened, and we need to get to what's called the root cause. So the root cause analysis is a process of discovering the origin or the root cause of the security event. Incident investigation involves analyzing data sources and performing a digital forensics investigation. So digital forensics is when you're going in and you're examining, what happened and what caused this. So with data sources, a log is a record of events that occur. Security logs can reveal the type of attack that was directed at the network and how it circumvented existing security defenses. Several problems associated with log management are due to the following: multiple devices that generate logs, very large volumes of data, and different log formats. Sometimes that can be an issue. So you have here an example of a dump file output. See the last write time, process name. So every time something happens, it's going to write it to the log file. Like if you go into your Windows computer and do the server management, you can actually see the event viewer, and you'll see the application events, the system events, the user events, and things like that. So data accumulated from a vulnerability scan can provide useful information. An SIEM dashboard can provide information collected from its sensors. This includes alerts, trends, sensitivity, and correlation data. Network Internet Protocol monitors can also provide an insight into an incident by creating automated reports on activities without the need for a user to manually analyze the data. S-Flow is a packet captured protocol that generates information based on capturing packets. In digital forensics, this is an important part of incident investigation because it uncovers the details behind that. As the forensics is the application of science to questions that are of interest for the legal profession. Digital forensics involves retrieval of difficult to obtain data, which is usually hidden, altered, or deleted by the perpetrator. A digital forensic specialist searches for evidence pertaining to cybercrime or to damage that occurred during the cyber incident. E-discovery is the electronic counterpart of manually sifting through the documents in discovery. So the forensic procedures. You want to secure the scene. You don't want to have the scene almost like the TV show CSI. You want to secure the scene. Contact a digital forensics incident response team and secure the scene immediately to avoid contamination, because you'll end up it'll contaminate the data and the decisions thereof. Preserve the evidence. Ensure that important proof is not corrupted or destroyed. Evidence should be placed in bags that have tags or identifying labels that record a description of the item, a numeric identifier, date, collection, location, and other relevant information. Okay, so here's an example of tamper evidence tape. Okay, that's then put on at a crime scene or at a cyber scene. So document the chain of custody. When a piece of information is captured, you have the recording officer, and then how does it go all the way to the storage? You need to make sure, because if ever this has to go to court as an evidence trail, you have to have clear evidence. The chain of custody documents that the evidence was given under strict control and no unauthorized person was given the opportunity to corrupt that evidence. That's where you have to be able to prove that in court. So examining for evidence, when examining for evidence, a device for evidence, there are specialized tools that should be used to gather evidence. You don't just open up the hard drive or go into the hard drive. Usually they'll use software digital forensic tools, and others they'll clone the drive and stuff like that. So it captures a system image or a snapshot of the current state of all current settings and data. Here's an example of an evidence chain of custody tracking form. So you list there whatever the item is, the description of the evidence, the chain of custody, who got it, when it was released by, was received by, and all the way down there. It's a chain of custody. So if it went through the hands of 5 people, all 5 people need to sign off on this document. Usually it should not go through that much. It should just go right from the data collector to the storage facility, or maybe to the investigator. So you want to examine it for evidence. The 2 common forensic software suites are EnCase and FTK Imager. Mobile device forensic tools are designed to perform forensics on smartphones, tablets, and other similar devices. When examining evidence, it's crucial to follow a specific order what's called the order of volatility. Okay, we'll see this in the next slide. Then you want to generate a report. A detailed written description of the acquisition and analysis of the evidence is required. That's the reporting. Okay, so here's the order of volatility. Registers and CPU cache, routing tables, ARP cache, process tables, kernel statistics, RAM, temporary file systems, hard drives, remote logging, monitoring data, physical configuration and network topology, and archival media. These are all important. Okay, so here's our knowledge check activity number 3. Which of the following is the process of discovering the origin or the root cause of a security event? TBS, XRX, BGP, or RCA? I know some of these have a lot of initials like this, but it's important that you know them and understand them. So the TBS, XRX, BGP, or RCA? Well, it's RCA, which is your root cause analysis. That's the process of discovering the origin or the root cause of that security event. Okay. And we've reached the end of the chapter here. So again, rate your competence of the following module objectives on a scale of 1 to 5, where 5 indicates you have full confidence in your competence of that objective, and 1 indicates that you have little confidence in your competence of that objectives. If you scored less than 4, you should consider reviewing the module and related exercises. Explain how to prepare for a cyber incident. Describe how to achieve resilience through redundancy, and describe how to conduct an analysis of an incident. Okay, so again, here's the summary. This is the end of the chapter. And I will see you in the next chapter. Okay, have a nice day.